find the probability of at least two girls. Again, there's that word at least, or the phrase at least. And again, at least and at most are two related phrases, but they mean completely different things. Again, at least means that many or more. So in 5 births, the probability of having 2 or 3 or 4 or 5 girls. And it says, assume that male and female births are equally likely and that the births are independent events. So we're not talking about identical twins or anything like that. By the way, male and female births are not equally likely. Biologically, it's somewhat more likely to have a female than a male. Just a separate aside remark. So it's not a 50-50 likelihood of having a daughter is more likely of happening. Not a great deal of difference in the probabilities, but there is a definite difference in the probabilities. I have 2 children, and they're both daughters, and I'm very lucky. I would tell you that those of you who think about, when you have children, you would like to have a son and so forth, the men in the group, I will tell you that having girls is wonderful as a father, because when you get into an argument with your wife, the girls always come to your defense. You're always the one that's right. Daddy's right, even when I'm not. So anyway, find the probability that at least 2 girls in 5 births are going to be females, assuming you're the equal probabilities, and round your answer to 4 decimal places. The title of this problem kind of gives away the concept behind it. It's a binomial problem. This is a problem that involves a binomial distribution. So on the, let's see if I have that in the PDF file. Here's the PDF file. Let's go down. If I went through and, well, I just explained how the problem's done. But the first thing you'd want to do is to ascertain if this is in fact a binomial probability distribution. And remember, there's the way that you do that for a probability distribution is to ask the question, is there a constant fit? And the word constant means a constant probability from one birth to the next. And here, the 50-50 equal likelihood tells us, yes, there is. Are there a fixed number of trials? That's the fit, right? The F in the word fit. There are 5 births, so that's the fixed number of trials. Are the birth of any one child independent from the birth of any other? And it says, assume that they are independent. So we're not looking at identical twins or anything like that, or triplets or quadruplets. So that's constant FIT, 2 possible outcomes, male or female. So, or in this case, we could say girl or not a girl. And then T, and that's it, 2 possible outcomes. So that's constant fit. So this does fulfill the criteria for it being, this being a binomial probability distribution. So we'd be able to do this problem using the binomial probability distributions on the calculator. The key here is, how do we find the probability of at least 2 girls in 5 births on the TI-83 or TI-84? And the way that that is done is using a distribution that is called a binomial probability distribution. And under the distribution button, going there, second distribution, and going up to or down to not the binomial PDF, that gives us the individual probability of an event. We want the cumulative probability. This is the function we're going to be using, the binomial cumulative distribution. the binomial CDF, binomial cumulative density function. The problem here is that this binomial cumulative density function sums up, cumulative being like your cumulative score in this course, it sums up the probabilities starting with the event 0. So it would take the event of 0 daughters in 5 plus 1 daughter in 5 plus 2 daughters in 5. But we want not, and that would be the probability of at most, right? At most is 2 girls or less. We want the probability of 2 girls or more. So how do we get this to work? Now, on the TI-84 plus Silver Edition with bells and whistles, you might be able to do it in another way with the input screen. But if you have a more advanced calculator than I have, good for you. It's excellent. Use it. To do this kind of problem, it might be good to look on YouTube, and you can put in specifically probability distribution of at least in the YouTube search function, and using the TI-84 plus Silver Edition or whatever, and it might you might get some good instructional videos on how to use your specific calculator to do that. But if you have a calculator like me, we're going to be using this binomial cumulative density function, but the way it's going to be used is as follows, and I'm going to go back to the home screen, second function quit, and whenever we have at least, we're going to use the idea of the complement of an event. So what is the complement of at least 5 births of at least 2 girls in 5 births? Well, the complement of that, the complement of 2 or 3 or 4 or 5 would be 0 or 1. So if we were to take the probability of all the events possible, 0 girls all the way up to 5 girls in 5 births, if we take all those probabilities and subtract off the probability of 0 or 1, then we'd be left with the probability of 2 girls in 5 births. So this is probably hard to fathom, but I've get this out of the way. I've tried to explain that here in this PDF file. So what you're looking at here is the probability histogram. In other words, we're looking at the event of 0 births, 0 girls in 5 births, 1 girl in 5 births, 2 girls in 5 births, 3, 4, and 5 girls in 5 births. And what we want to have is we want to know what is the sum of these probabilities, 2, 3, 4, or 5. Now the calculator only sums up going in this direction using the binomial cumulative density function, the CDF. So since it only sums up going from left to right, starting at 0, what we do is to say, well, let's take everything. In other words, the sum of all these probabilities, because this is a probability distribution, we know is going to be equal to 1. So the sum of all of these bars, so to speak, is 1. And to be left with 2, 3, 4, or 5, we can subtract off this much of it, 0 and 1, from 1, 100% probability here, everything, and be left with 2 or 3 or 4 or 5. So the way that that gets done on the TI-83 or TI-84 is to type in 1, and I can do this on the calculator since we got this up. You type in 1 and then minus, and use the blue minus key, not this negative key, minus. And now we would type in or select out the binomial CDF, right, the cumulative density function. So again, where that is, under second distribution, and then you can scroll down, all the way down, 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 and whoop, past it. There it is, binomial CDF, in it goes. Now the syntax for this is, first of all, the n, in other words, how many events in total are there, and there are 5 births. So this is a 5. Then a comma. Comma is above the number 7. Now the probability of the event of having a girl or having a boy, equal probability, we're saying 0.5, even though it's really not, but that's okay. So the probability of a girl is 0.5. And now what we want to do, because we're going to be subtracting off everything up to this number that we're going to put in, is going to be not the number 2, because that would leave us with 3 or 4 or 5. We're going to be left with 2, so we're going to subtract off everything up to 1 and including 1. So we type in 1, and we can close the parentheses or not, it doesn't matter. And when we press enter, here we have our answer. So the correct answer for this problem, 0.8125, we would put here 0.8125, and when we check our answer, we're correct. Now let's see, let's go back to the PDF here. And what I did here, I forget some of the things I do. What I did here was, it says in a binomial distribution, word problems, when you're asked to find the probability that at least a given number, let's say A, at least A, in our case, this was at least 2, you always use for at least, now this is concentrating on the word at least, you always use the 1 minus the binomial CDF, then n, which is the number of trials. In this case, that was 5 births. The probability of that event, probability of a girl in this case, was 0.5. And then this last number that you have here is 1 subtracted from A. So here we had at least 2. So we put in 2 minus 1, 1, which is what we put in over here. If it had said at least 4, we would put in everything that you see here, except this last number would have been 4 minus 1, or 3. And that would have left us with the probability of 4 or 5 girls in 1 birth, in 5 births.